Good morning, class. My name is Bamishebi Samson, and I'm the tutor for this CSC 102. As we all know, CSC 101 is the prerequisite of this particular course, and we are going to introduce you to broad introduction to programming methodology and algorithm, with the emphasis on problem-solving strategies and techniques for developing and documenting applications. We are also going to cover including principles of structured programming, problem decomposition, program organization, the use of procedural abstractions, and basic debugging skills. This particular course, we are going to use Visual Basic Programming Language, which is going to at least help you to build on what you have at least learned in the basic language. It will be a vehicle to illustrate many concepts. Introduction to Programming VB.NET. Introduction to the VB.NET language, the .NET framework, developing desktop application, controls, common dialog box and menus, and also developing browser-based application, web service, Ado.NET, and developing database application. So before we delve into, as you all know, we have said that it is introduction to computing. Then before we now delve into objective of the course, we will try as much as possible to at least let you know that yes, computer is quickly evolving from 21st century all-purpose devices, which is quite different from earlier computer, which are very too large and very expensive, and they were confined in a particular laboratory of certain institutions. Only computer engineer will be able to at least program them. But now, basic uses were limited to doing difficult computation in engineering and sciences. The computer is no longer only used in laboratory. Computer and computing in general are now present in practical everything we do. Computer and computing in general are now present in particularly everything we do. We use computers in spreading. We use computer in different fields. We use it in space science, aviation, financial institutions, social sciences, humanity, and military, including transportation. We use computer there. But like I said, the objective of the course is going to be to assist students in recognizing the different types of software and their applications, to enable the trainees, which is the student, to comprehend the hardware and software that make up a computer. Another objective is to offer fundamental grasps of the evolution of the computer, as well as computer types and classification. When we say evolution, that means generation. I'm going to go into details of that evolution. So to also introduce students to programming in computer with a focus on the stages, building block and development of computer programming in Visual Basic. I've said it earlier in the course outline. And to also spread the knowledge about potential computer risk early in the studies of computer. So, like I said, I hope you guys are with me. Understanding the computer. Over the year, the computer has evolved into what we see today. And this unit make an effort to present many turning points. And turning points in the evolution of the computer in chronological order. The evolution of computer is divided in generations from first generation to sixth generation. Then the evolution of computer is divided into, and like I said is divided into generations. So we expect the students, or it is expected from the student that at the end of this section 1, unit 1, we expect the student to be able to identify computer based on their historical classification. So let's now go into general overview 1. So if we are talking about general overview of computer, we can't talk about general overview without definition of computer. I remember in our CSE 101 we defined what is computer several times, so that we can have a broad knowledge what is computer all about, so that it will not be just primary definition that you guys are having in secondary school. So when we say what is computer, we are basically defining it as a tool or a machine used for processing data to give required information. And what is data? So data is referred to facts about a person, object, place, name, e.g. we have the name of the person, age of the person, complexion of the person, the school the person attended, the classes the person, height, the complexion, and several other things. Those are data. Then when that data is now processed, it becomes an information. So when we say information to, let's say, what is now information? So we now say, what is information? If you are asked by anybody what is information, you should be able to tell them that information is referred to as processed data. You know, we already have data. Most data, we don't need them when they are not processed. But let's say we want to now compute data for maybe possibly for an ID card or for name, NIN. So it becomes an information that is going to be used in several channels. So for that, a data that is processed is called information. A meaningful statement like e.g. net payment of workers. So you will need the name of the workers, you will need the salary that the worker takes, you will need the identity number of the workers and several other things to identify, so that there will not be mismatch of such person's identity. That is when such data become an information. So, and they went further to tell us that a computer must be capable of what? Taking inputs through different input devices like keyboard, mouse, joystick, and you know, touch pen and several other input devices. And then how does it store all those data or information that it takes? It stores them in the hard disk, hard drive, diskette, flash drive, you know, and also it can also be stored virtually in some other locations, like many big data that we have. Some of them are cloud-based data whereby it is stored. So computer is involving in different. Then how does it display all this information that it gets? There must be a way that people can visualize the result of the data that is being input into computer. How do they do that? They do it through the display units, either a TFT, either an LCD, either a visual display units. You know, monitor, screens, or whatever name that you can at least give to it. So meaning that the computer must be able to take in information, it must be able to store that information, and it must be able to produce results of those information. Those are the general overview of it. Do you get me? Like they said its application transcends science, engineering, communication, space science, aviation, financial, social science, humanity, military, transportation, manufacturing, extract industry, to mention those few. This unit presents the background information about computer. These units that we have give you the entire background of computer. So, and everything has been mentioned to you. So, let's just continue. Let's move to characteristics of computer. So that is what makes a computer to be. What are the characteristics? What are the different attributes that makes up a computer? One of it is speed. When we say speed, the computer can manipulate large data at incredible speed and response time, meaning that a computer should be able to process data within a short period of time, and those data must be what? Must be, no matter how large they are, it must be able to produce or to be able to turn those data into information within a short period of time. So that is why a computer must be fast. The first objective is it must be more faster than what ordinary human can process. If a human is asked to arrange 100,000 of files here, or 10,000 files, 5,000 files, it can take the human a whole week. But a computer should be able to do it within less than 30 minutes or thereabout to process those data, large data. Then, in the course of processing those data, another characteristic is the computer must be what? Must be accurate. Those information that is processing must be what? Must be accurate. That is what takes us to accuracy. Its accuracy is very high and consistent, can be relied upon. Errors committed in computing are mostly due to human errors, meaning that whatever errors that is committed during the processing of data is caused by human, because it is garbage in, garbage out. It is what you give into the computer that is coming. So if your program is very sophisticated from the beginning, definitely you will not be having errors when the computer is producing a result. That's what they mean by accuracy. That is, even if the larger the data is large and is able to process those data within a record time, but whatever thing he process, it should give an accurate result, not disjointed, not incorrect, or not result that contain errors. Now, the next said another attribute is that whatever thing is able to process within a short period of time, and whatever accuracy of that data, it must be able to store it somewhere. So that is why the storage system is being created both internally and externally. So we have some of these components in the computer. Some of them have cache, they have buffer. Even if when system shuts down abruptly, they can hold that data for certain period of time before they can discard it, which make it easier for, by the time the system reboots, you might be able to retrieve the data. That is temporary. And the one that the computer is able to store permanently, it will store it in a particular location, either in RAM or ROM, or in hard drive, or external hard disk, or a cloud-based storage system. So, meaning a system must be able to do that. Then they said the memory are in kilo, because they are in modules starting from 1024 memory location. So each time it opens, the individual has little or no instruction to give again. Reliability, that is another attribute, is that the system must be reliable. Everything that the system or the result that the system is producing must be what? Must be reliable. That's why they say, being a machine, a computer does not suffer human trait of tiredness and lack of concentration. It will perform the last job the same way it will perform the last job the same way it performed the first job. So human being, we get tired easily after some time. So, and we commit several errors in the course of our tiredness. So, but computer, if a well-structured program system should be able to be reliable because it doesn't suffer tiredness. So computer can continue to run for 24/7 for several months and continue to produce the same results as if the same way it produced the first result. So the current result that he produced must be accurate with the first result that he has produced years ago. If the system suffers for reliability, such system require to be changed. Or when the system becomes dragging, require to be upgraded. So there's flexibility. They say it can perform, this is another attribute, another characteristic, it can perform any task, any type of task, once it can be produced to logical steps. So we know we have supercomputing, we have special purpose computer, then we have general purpose computer. So for general purpose computer, it should be able to perform different tasks. And the special purpose computer, whereby it is designed for a process like an aviation system now, that is designed purposely for aviation operations. So whatever activity that is carrying out in that area, whether weather condition, flight management, client crew scheduling, and every other activities, all those activities, it must be flexible enough to be able to execute those process and those activities without having any problem. And the same thing goes to general purpose too. It must be able to carry out different tasks and give and deliver them as at when due. So these are characteristics that you as a student, you must be able to be aware of it, and you must be able to at least have it at your fingers as you proceed on this course. Then that takes us to historical overview of computing. So we said first generation electronic computer started in 1937 to 1953. What are those things that were being made in those? So they were just electronic components. Had one major benefit. However, they could open and close about 1,000 times faster than mechanical switch. The first generation proposed reprogramming electronics computer was what? Numerical integrators and computer. It was popularly called ENIAC, and it was built by J.P. Presper, Eckert, and John von Neumann. So they were from University of Pennsylvania, and they did an incredible work at that time. So then the first generation, which I said that it was done by John Neumann and Eckert Macaulay, they were consultants to the ENIAC project, and they began work on a new machine before ENIAC was finished. Do you get? And the main contribution of EDVAC, their new project, was the notion of a store program. ENIAC was controlled by a set of external switch and dies. To change the program requires physically and altering the setting on the control. This control also limited the speed of internal electronic operation. through the use of memory that was large enough to hold both instructions and data, and use the program stored in memory to control the order of arithmetic operations. That was in first generation. Then in second generation started in 1954 to 1963. Are you with me? I said this system, the second generation was several important developments at all levels of computer system design, from technology used to build the basic circuit to the programming language used to write scientific applications, whereby electronic switches in this era were based on discrete diode and transistor technology with a switching time of approximately 0.3 microseconds. Don't forget that the first generation to be built with this technology include Tradic at Bell Laboratory in 1954 and TX-0 at MIT Lincoln Laboratory. Memory technology was based on magnetic core, which could be accessed in random order, as opposed to mercury delay line, in which data was stored as acoustic wave that passed sequentially through the medium and could be accessed only when the data moved by the input and output interface. So these are very very important situation of how, and most of those things that were done in that time, at least during this second generation, many high-level programming languages were introduced, including Fortran 1956, Argo 1958, and COBOL 1959. So the third generation computer, which started in 1963 to 1972. The third generation brought huge gain in computational power. Innovation in this era include the use of integrated circuits, or ICs, semiconductor devices which several transistors built into one physical component. Semiconductor memory starting to be used instead of magnetic core. Microprogramming as a technique for efficiency design complex processor. The coming of age of this pipelining and other form of parallel processor, and the introduction of operating system and time sharing. You see, operating system came into existence in third generations. So meaning there are progression. We look at many examples of those third generation is GDS 6600, IBM 360/91, IBM 360 F195, then the Solomon computer, then we also have ENIAC 4. The generation computer at programming language of third generation computers, Cambridge and the University of London cooperate in development of CPL, that is Combined Programming Language, in 1963. These were ages that are very important, and this was what led to fourth generation in 1972 to 1982. So fourth generation, this generation of computer saw the invention of large-scale integration, whereby we have 1,000 devices per chips, and very large-scale integration, that is both large and very large, came into existence in fourth generation. In the construction of computing elements, at this scale, entire processor will fit into a single chip, and for single system, the entire computer processor, that is main memory and input and output controller, can fit on a chip at that time. On a chip, gate delay drop into about 1 second per gates. Semiconductor memory replaces core memory as the main memory in most systems. Until this time, the use of semiconductor memory in most systems was limited to register and cache. Now, I mentioned cache during introduction. You can go and Google, you can find out what it's all about. During this period, high-speed vector processors such as Cray1, Cray SMP, and Cyber 205 dominated the high-performance computing scene. So, development in software also include very high-level languages such as FP, that is function programming, and prolog programming in logic. This language tend to use a declarative programming style as opposed to imperative style of Pascal, C, Fortran, et al. In a declarative style, a programmer gives a mathematical specification of what should be computed, leaving many details of how it should be computed to the compiler. You know, we taught this compiler in our 101 and or routine system. The language are not yet in wide use, but are very promising as notation for programs that will run on massively parallel computer systems. Compiler for established language started to use sophisticated optimization techniques to improve code, and compiler for vector processor were able to vectorize simple loop, turn loop into single instruction that will initiate and operate over an entire vectors. An important event in this development of computation science was the publication of last report. In the last report in 1982, the U.S. Department of Defense, DoD, and National Science Foundation sponsored a panel on large-scale computing in science and engineering, shared by one Peter D. Lass. So, in the last report, stated that aggressive and focused foreign initiatives in high-performance computing, especially in Japan, were in sharp contrast to the absence of coordinated national attention in the United States. The research had inadequate access to high-performance computers. One of the first and most viable of the response to the last report was the establishment of the NSF Supercomputing Center, Phase 1. Now, the NSF program was designed to encourage the use of high-performance computing at American universities, which take us to the fifth generation in 1984 to 1990. So, the development of fifth generation of computer system is characterized by mainly acceptance of parallel processing until the time of parallelism was limited to pipelining and vector processing. The scale of integration of semiconductor continued at an incredible pace. By 1990, it was possible to build chips with millions of components, and semiconductor memory became standard at the increasing use of simple user workstations. Because it was in that age that we now started having laptop, it was in that age that we now started having workstation that comprises of your monitor, your system unit, your keyboard, your mouse, and the likes, which now take us to the sixth generation. And the sixth generation is what is still evolving up to date. This generation is beginning with many gains in parallel computing, both in the hardware area and improved understanding of how we develop algorithms to exploit devices. Massively parallel architecture, parallel system now competes with vector processors in terms of total computing power, and most especially parallel system to determine the future combination of parallel computers. The workstation technology has continued to improve with processors designed now using a combination of RISC, IRSC, pipeline, and parallel processing. As a result, it is now possible to procure a desktop workstation that has the same overall computer power of 100 megaflop as fourth generation supercomputers. This development has sparked an interest in heterogeneous computing. A program started on one workstations can find idle workstations elsewhere in the local network to run parallel subtasks. So we have like I said, these are the area whereby we now found ourselves that TI transmission rates are now standard for regional network and the national backbone that interconnects regional network. Using TS network technology is becoming more widespread than its original strong base in university as government laboratories. So you can see a little over a decade after warning voiced in the last report, the future of strong computational science infrastructure has brightened, and that is what is still evolving up to date. So my dear students, you don't have any issue regarding this course, because I believe as we are starting, we will progress to a greater height, and then we will be able to do the needful as we progress. There is a pilot question that is attached to this unit of this section, which I expect each and every one of you to attempt. Then though, I will structure how we are going to attempt it in your LMS so that you can easily follow it up. The pilot question is direct. It says differentiate between computers from the first generation to the fourth generation. You know, I treated 6th generation now, but I'm asking you to help me to treat it from first to fourth generation. With this, we have come to the end of this class. Thank you all and have a great day. We meet again.